Welcome to our learning session number 9, Sweep, Helical Sweep, and Helical Sweep Cut. I'm Trisha from Product Labs. After completing the session, you'll be able to understand that sweep is a process of creating a 3D object by sweeping its 2D cross-section profile along a given path or trajectory. Sweep cross-section is always perpendicular to its trajectory. Unlike an extrude, part can't take any irregular shape depending upon its sweep path. So let's get started with Session 9 on Sweep, Helical Sweep, and Helical Sweep Cut next in this series.
In this session, we'll be learning as how to create sweep feature. To create sweep feature, we require two things. First is sweep profile section, and second is sweep path along which section has to be swept. First, we'll sketch sweep path, and after that, sweep profile section will follow that. So, let us click on Sketch and create the sweep path. We are sketching a spline as sweep path. Click on OK button now. This is the sweep path or trajectory. Now click on button labeled as Sweep on the top menu bar. Now we have to create sweep profile section, but before that we need to select the sweep path. So we'll select this path as sweep path reference. And now click on this button to create sweep profile section. Our sweep profile section is a hollow tube which will be drawn here. Also, sketch plane of this section must be on the start point of sweep path. Click on OK button upon completion of sketch. Now, sweep feature is ready. We can notice that sweep profile section has traveled along the sweep path shown in green color. Now, if we want, we can edit the sweep profile section from here and give it an entirely different shape. This time, we are going to make the shape of the panel keeping the sweep path same. So, let us sketch the profile cross section. Trim off unwanted lines. Click on OK button now. Sweep is ready now with different profile. Click on OK to finish it. Press Ctrl+D to fit the model into screen. So, that's all about sweep feature. Next, we'll be learning about helical sweep. Let us open a new part file. In helical sweep, path or trajectory is predefined, which is a helix, and sweep profile cross section could be any. Now, we'll be selecting helical sweep option from top menu. Click on Reference tab and then click Define. Select the sketching plane and orientation and click on Sketch button. Make the sketch plane parallel to screen. Right-click and select the option Axis of Revolution. Now draw a vertical axis. This becomes revolution axis. Now draw a line equal to the height of helix, and its distance from center axis should be equal to the radius of helix. Or else, we can define the helix diameter also. Adjust the dimensions as needed. Now click on OK button. Now we have to draw the sweep profile cross-section. For that, click on this icon. We are going to model a spring, so the cross-section is a circle. Circle has to be drawn at this intersection point, which is the starting point of helix. Circle diameter is same as the diameter or wire thickness of spring. Now click on OK button. We can see that spring is formed. Pitch of the spring can be changed from the menu in the top left corner. Click on OK button to finish. We can change the profile cross-section from circle to any other shape. For this, let's get into edit mode by right-clicking. Now, edit the section profile by clicking on this button. Next, we'll change circular section to square section. We have spring reformed, but with a different cross-section. Change the pitch of helix in this input field. Or else it can be changed from here as well. Now click on OK button to finish. With this, we are done with helical sweep. Next, we'll be learning helical sweep cut feature. Let us open a model of a screw without threads. Unlike helical sweep cut will remove the material along a helical path, and thus it would form the threads on the screw. Now, click on the button labeled as Helical Sweep in the top menu bar. Now, click on the References tab and then Define. Now, we'll be sketching the cross-section profile of helical cut, and also we would define the diameter and height of helix. Define the sketching plane and orientation as usual and click on Sketch button. Right-click anywhere and select Axis of Revolution option from the pop-up menu. Since threads have to revolve around the center of screw shank, so create the revolution axis along the shank axis. Now define the height of threads by drawing a vertical straight line. For that, we need to define references first. Now, click on OK button to finish this. It's time to draw profile cross-section. So, to draw profile, click on this button. This is the start point of thread. So, profile sketch has to be drawn here. We are assuming that thread cross-section is triangular and therefore sketch should be a triangle. We can dimension it as needed. Click on OK button to finish. Since this is helical sweep cut, so we'll have to choose Remove Material option here. Now, helical sweep cut is done. Helix pitch and other parameters can be edited from here in the top. Click on OK button to finish. Now, threads are formed in the screw, which completes the helical sweep cut. Press Ctrl+D to fit the model and save.
Welcome back, guys. Let us do an exciting practice exercise and create the object displayed on my left side. So let's begin.
Now look at this drawing carefully. During next few minutes, we'll be working on it to create 3D model for this. Notice that it has a U-shaped sweep profile. And then it has threads on either sides, which are nothing but helical sweep cut features. These are some of the important dimensions we would need to create this path. Now, open this model to understand the steps involved in creating this. You can see various steps and features listed out in model tree, which are used to create this path. The first step is to create the U-shaped sweep path. After that sweep, a circular cross-section profile along that path. After sweep, model would look like this. Next, we have to add chamfers at both ends. Now, create axes on both cylindrical shapes. Now, we'll make helical sweep cut to form threads. Now, the final part is ready. Now, we'll create this part from scratch. Let us open a solid part file and name it as Sweep Helical Cut Practice. And then press OK. Now select the unit system and press OK. Now, we have to sketch sweep path. So, click on Sketch and draw the sweep path according to the dimensions given in the drawing. If you have any doubts on sketching methods, please refer to our sessions on sketching in this series. Now the sweep profile is ready. Now we have to click on Sweep button and perform sweep operation. So we need to create sweep cross section at the start point of sweep path. Now select the path curve and click on this icon to draw the cross-section profile. In this example, cross-section is circular, so we need to draw a circle at the start point of sweep path. This is the start point of path. Draw a circle and dimension it. Now click on OK button. Now that circular cross-section has swept along the U-shaped sweep path, click on OK button to finish. Next, we have to create threads at both the ends by using helical sweep cut method. Before creating threads, we'll create chamfer on both the edges. Select the individual edges for chamfers. Now, create axes at both ends. Now, enable axis display. Select Helical Sweep option to proceed. Now, click on References tab and click on Define button. Enable Plane Display from Quick Access toolbar. Now, select the sketching plane and orientation. Now click on Sketch button to proceed. Now draw helix sweep cut profile, which is a triangle. Draw references for sketch. Now right-click and choose the option Axis of Revolution from the pop-up menu. And then draw it. Now draw a vertical line up to the point we want the threads. Next, add dimension to this line. Click on OK button now. To define the sweep cross-section profile, click on this icon. Now draw a triangle at the start of sweep path. Dimension the sketch now. Now, click on OK button to proceed further. Ensure that this button is clicked to remove the material. Change the pitch of threads as needed from here. By default, threads will be right-handed. But we can change it to left-handed or right-handed using these two buttons. Now click on the OK button to proceed. Now we have completed thread formation in one side. Press Ctrl+D to fit the model into screen. In the same manner, we can create the threads on the other side as well. Size, shape and dimensions of the threads are same for both the sides. Click on OK button after sketch is complete. Now, thread formation is complete in both the sides. Now, if you notice that sweep path sketch is visible here in green color. So, if we have to hide it, we'll have to do it in layers. So next, we'll go to layer tree from here. These are multiple layers which contain various entities like datum planes, axes, points, sketches, and so on. Now we have to hide the layer which contains the sweep path curve. Let us select this layer and hide it. It contains sweep path. And save the layer status by right-clicking on the text layers. Now press Ctrl+D to fit the model into display area. So with this, we have completed the learning session on sweep function in Creo. Thank you. Next, we'll be learning about blend feature. To do this, click on the tab labeled as Shapes and then click on the option Blend. Please note that blend operation is performed by using two or more cross sections of similar types. Therefore, we need to define the cross sections to be used for blend here in this window. We'll define the sections by sketching them. We have drawn a square as a first section. Next, we'll add second section by clicking on Section tab once again. Before sketching second section, we have to define offset value here in this box. This offset value defines the distance between two sections. Now, click on Sketch button. Again, draw a square as a second section. Now, click on OK button to proceed. We can notice that blend operation is completed and object is formed. Notice that Section 1 and Section 2 have merged to form this object. Also, we can see the offset distance of 80 mm between the sections. Now, press Ctrl+D to fit the model into graphical area. Similarly, we can blend even more than two sections as illustrated here. Let us edit this model now and create third section at a distance of 50 mm as shown. Click on OK button to complete. Now we can see all three sections are blended together. Click on OK button to finish. With this, we have completed session number 9. Thank you.
If you have any questions, you can find us on social media. Thanks for tuning in and have a great day.